Hey y'all, it is your boy, Mr. Thibodeau. Let's go ahead and jump right into lesson 97. So, similar triangles and indirect measure. Okay, well, now I like these guys a lot because they are quite simple, in my opinion. So, similar triangles are triangles that are basically identical, with the one exception that one of them may be slightly bigger than the other one, and thus the other one is slightly smaller than the other one. So, over here, these two triangles are similar. Okay, what that really means, right? If one's bigger than the other, then how are they that similar? It means that their angles are the same, okay? Which is really cool because it means that we can then use the angle of one to figure out the angles of the other. It also means that there is going to be a ratio between their sides. I don't think you have to get into that just yet, maybe? Oh yeah, it's right here. Okay, um, so let's go ahead and do some of this. So similar triangles, tick marks. So that angle is the exact same as this one. Those two are the same. And C and X aren't marked, but they're obviously the same, right? Because if you get two are the same and each triangle has to equal 180, that third angle has to also be the same. Okay. So we get corresponding angles up here. Let's see. So there are ratios that are formed. Okay. If this one is 10 and that one is 5, okay, and I know they're similar, then the next one over on the other side, okay, if I multiply 5 by 2 to get to 10, then I'm just going to go ahead and say right now that the other sides are 6 and 8. They're 6 and 8. Magic! Okay. So there's a number of ways you can solve that. If you figure out what the dilation factor is, which is called which in this case was 2, it's how much bigger or how much smaller it is between each other, you can then just apply that to everyone. The other option is to go ahead you can create a ratio. 6 over 3 equals 10 over 5, okay? Which is accurate, right? So 6 divided by 3 is 2. 10 divided by 5 is also 2. But let's say I didn't know one of these. In fact, let's go ahead. Over here, I have 6 over 10, and then I'm going to have 3 over a. Okay? It's important that if the 6 is over the 10, the 3 has to be over the a. Okay? That's the important thing. Now, it really doesn't matter here. If I wanted to, I could have, I could have used this side here if I knew it on that side, but I don't know what this one is, so it doesn't really help me here. But it really doesn't matter which two you use as long as when you set it up, you only have one piece of missing information, okay? It doesn't help you to have two pieces of misinformation because we can only solve if we have a single variable and an equal sign, okay? So now we have a few different ways to do this. If we wanted to, we could do 6 divided by 10 and then use that 0.6, 3 times 0.6 to get my a or whatever. I guess it'd be the other way around. But in any case, what we're going to do is an easier way. We're going to cross multiply, okay? So 30 equals 6a. Divide by 6 on both sides because I need to isolate that a. So it says a equals 30 divided by 6 is 5. A is going to equal 5. Okay, perfect. This isn't too difficult. Now, the cool thing about this is we can use this to solve unknowns. And one of the main ways to solving unknowns is, let's say I need to figure out how tall this tree is. I can use a few simple things in order to figure out how tall one other thing is. So if I stand here and the tree's here, really you'd want to stand closer to the tree to make sure you really get the same angle, but it's fine. The sun is going to be affecting both of us at the same, right? We're both straight on the earth. How it hits us, it's going to create the exact same angle here. So and I'm standing straight, and we're considering the tree to be standing straight, okay? Now, we have the same angles, so they're similar triangles. If I know how tall I am, we could figure out how much my shadow is. Might be a little tricky, but doable. Once I have two pieces of information on this triangle that I've made, I need one piece of information from this triangle. I could either use, if I know how tall the tree is, I could use that. If that's what I'm looking for, then I need to measure from here to here to get that. I just need to have one piece of information, okay? Once I have three pieces of information, I know Beth's height and the length of Beth's shadow, and then I find out the tree's shadow, 30. Now I can do the all of the math to figure out the height of the tree. Okay, so this is very helpful, especially when we know, say, like the height of a building. Okay, those are all on file. You could look that up extraordinarily quickly. What's the height of the building? We know our height. Okay, we can measure out the shadow with reasonable ease. And then once we know three pieces of information, we can solve everything else. Okay. So some pretty cool stuff that we can do with this. The Greeks use this a lot. This goes into telemetry and a few other things as well. Okay. Okay. Cross multiply. This times this. This times this. 100 times 24. Okay. And unknown versus 40. Okay. So let's see. I think that's all you really need. I think you can solve it from here. I'll have you guys do 1 through 29 odd for your work today. Just make sure that you are comfortable with cross multiplying. Okay, and that's all.